Okay, integrals is net change. So this is applications of the integral. These are some of the rules we have. Displacement. How far you've gone from time A to time B, or actually how far you are from where you started. Remember, there's a big difference between distance traveled and displacement. The winner of the Indianapolis 500, they had traveled 500 miles during the entire race. But the start and finish line are the same place. So between the start and the finish, their displacement is 0. Because they ended the race where they started the race. Right? Particularly, you got the guy on the pole. The green flag drops and the guy on the pole starts the race. When he finishes the race, the checkered flag drops when he crosses the finish line. It's the exact same spot. His displacement is 0. He's traveled 500 miles, more if you include the going off the track in order to go into the pits, but his displacement is not up. Difference between displacement and total distance traveled. So displacement is the integral of the velocity. Total distance is the integral of the absolute value of the velocity. We'll talk about how to deal with that in a minute. And the change in velocity is essentially the same thing as displacement is change in position, right? That's what displacement is, change in position. So the change in position is the integral of the velocity. Change in velocity is the integral of the acceleration. And I have down here, don't forget the other things we talked about with motion. If you know position, you can find velocity by taking the derivative. You can find acceleration by taking the derivative of the velocity. With integration, you can go backwards and go the other direction. Now we can go both ways, and we can solve all kinds of motion problems. I can give you the equation for the velocity and ask questions about where it is, where it moved, and ask questions about its acceleration. And all I have to do is give you one equation, and I can ask you stuff about other things. Okay, that's one of the big things. Remember, calculus was invented by Newton to solve motion problems. That's why we like motion problems when we talk about calculus, because it goes to its roots. Is it useful for other things? Oh, dear Lord, yes. But this is where it started. So I always like to go back to our roots. That's why a lot of calculus books are all concerned about motion, because that's the roots of the mathematics. Okay. So, first example. A particle is moving along the x-axis with the velocity v of t equals t squared minus 7t plus 10. With t goes from 0 to 10. We don't care what happens in negative time, because we do not travel backwards in time. It has been proven impossible. No, it's been proven you can't move backwards in time. Ever. No mechanism will exist. And we don't care what happens after 10 seconds. That's the only time period we do it. And time equals 10. We don't have a time value, seconds, minutes, hours. We don't know milliseconds. We don't know. We don't care. Because we have time. We don't have the units for time. We don't have the units for its position, but we know it's just along the x-axis. Where is it on the x-axis? This is also known as rectilinear motion. You may see it moves rectilinearly. Ooh, that means it's going back and forth and back and forth and back and forth and back and forth. So you got a particle just going back and forth along the x-axis. It's called rectilinear motion. They love questions about rectilinear motion because you can ask lots of things. This is some of the basics that they do. They go, find when it is stopped, moving to the left and moving to the right. Well, that's easy enough. When the particle is stopped, what does that mean? Its velocity is 0. So t squared minus 7t plus 10 equals 0. Can you solve that? If it is a complicated equation, use your solver on your calculator. However, this is a simple polynomial that factors into t minus 2, t minus 5, so it stopped at t equals 2 and 5. That's when it stopped. It's moving to the left when the velocity is negative, moving to the right when the velocity is positive. Here's what you want to do. Set up a little sign chart. That's the easiest thing to do. This is the easiest way to do it. And plug it into the original equation and figure out when the velocity is positive and negative. Just pick a point in between. And here's what's really cool. I'm going to plug it in the factored one. Pick any number between 0 and 2. 1, it's a number between 0 and 2. Very easy number to work with. If I put 1 in for t, this is negative. Put 1 in for t, this is negative. And negative times negative is a positive. Pick a number between 2 and 5. 3. Put 3 in here, I get a positive. Put 3 in here, I get a negative. And positive times a negative is a negative. I don't care about the actual value. I just want to know its sign. Pick a number larger than 5. Let's say 8. 8 minus 2 positive. 8 minus 5 positive. It's moving to the positive. So it moves to the right, moves to the left, moves to the right. That's what you need to know. Now, I don't have enough room here, but if this were a question, what would you need to have? You would need to write out a statement. It is moving to the left. Let's say it's moving to the right when x is between 0 and 2. It's moving to the, and from 5 to 10. That's when it's moving to the right. This is moving in the positive direction. It's moving to the left from 2 to 5. At 2 and 5, it stopped. Remember, at those points it stopped. It's not moving to the left or to the right. It stopped. Those are not included in your intervals. If you want to write it in interval notation instead, 0, 2. Open intervals because it's not at 0 and 2. Does that make sense? Okay. Question. Does that make sense? Often you need this for a particular problem in order to set things up. Now, part B. If the particle's starting position was x equals 4, where did it stop? What are we talking about here? We're talking about displacement. How far is it from where it started? Where it stopped is how far away from where it started. Not how far it's traveled, but where it is from where it started. I could start here and end here, but that does not mean that that distance is the only distance I travel. I could be running all around the room and just stop here and down all over the round room, but this is how far I am from where I started. That's displacement. So what I need to do on this, where I started plus my displacement. Where I started plus whatever my displacement is. My displacement is the integral of the velocity. How far I am from where I started. Notice I did not write the equation. I did not put in the integral of t squared minus 7t plus 10. I can. Those two are equivalent answers. Those two are equivalent answers. Okay. You will see when we start doing practice questions together, AP never writes the equation down unless you are creating the equation. They almost never do that. Their answer, they would say they would give this equals whatever the numerical value you get from doing this. You would not have to write the equation in there to get full credit. It's the integral of the velocity from 0 to 10. This is what I'm looking for. This would give you nearly full credit. I still need to have the numerical answer next to it, as they would as well, unless they say do not solve. And I may say on some of my questions, write but do not solve. And it's always funny when you put those words, write but do not solve. And you got some stupid kid spending forever on that question trying to solve it. Because they didn't read the instructions. Well, I would have finished the test if I had spent forever on this question. What did this question say? It said write the equation. It did not say to solve it. It said write the equation. Yes, I was together with 2 other calculus teachers from this district on last Saturday, and we were bemoaning some of these things that our kids do that should be smarter than that, but they do it anyways. Okay. I don't know what the answer is off the top of my head. I think from last year's notes it was like 87 or something like that. I really don't care at this point. Putting the calculator figures out. And I'm not worrying about the answers right now. I think it ends up being 87 something. I think that's from last year's notes. I saw that. Is that what you got? 87 in the third. Okay, 87 in the third. I tried to do it with my calculator this morning, and I didn't get the right answer. Didn't get the same answer. I'm going, I forgot how to do it on my calculator. I got to go back and relearn how to do it on my calculator. Okay. By the way, it won't help you during the AP test. Desmos does numeric integration really well. You type this, you can type this into the calculator into Desmos, and it won't graph it, but it will solve. It will give you the answer. It does numeric integration really well. So it's a great way to do it. In fact, that's what I tend to do when I check answers on tests. Well, I do that. Okay. It won't graph it in. It won't graph it, which really sucks. That's okay. So the next part's where things get a little interesting. What was the total distance traveled? Well, what did I say? How do you find the total distance? It's the absolute value of the velocity. The integral from 0 to 10 of the absolute value of the velocity, which is not the absolute value of the integral. The integral of the absolute value is not the absolute value of the integral. Typing this into your graphing calculator can be tricky. You may be tempted to use. On some calculators, I think the 84 has it. On some calculators, they got a bar, straight line bar that looks like, ooh, that looks like the absolute value sign. Looks like a half a parenthesis, right? Same thing. You got a straight line. Ooh, that straight line, then the straight line. No, that's not what that is. It is not an absolute value bar. You have to type in ADS or absolute value or whatever the keys are for that. It's really not the easiest thing to do on a calculator. Learn how to do it. However, let's say this is a non-calculator portion of the test. Because this is a perfectly valid non-calculator question. Because taking the antiderivative of t squared minus 7t plus 10 and then plugging in 0 and 10 is not a hard thing to do by hand. Not the easiest, but not the hardest. The numbers would be easier to work with, I guarantee. It's a non-calculator question. So what do you do if you don't? What if you can't take the integral of the absolute value? Because remember, you can't take the derivative of an absolute value either. Remember, we can't take, what did we do if we had absolute value? You broke it into 2 equations, into piecewise, and took the derivative of each piece. You cannot take the derivative of an absolute value. You cannot integrate, except your calculator can do it, an absolute value. However, we're smart people. Here's what we can do. We can break it down into parts. When Does it change direction? Yeah, we figured it out. It was 2 and 5. So we do an integral from 2 to 5 of v of t dt plus an integral from 2 to 5 of v of t dt plus an integral from 5 to 10 of v of t dt. However, if we do it as it stands now, what do we actually have? We actually have the displacement, because some of those values are going to be negative. Which ones are the ones that are going to be negative? When it's moving to the left. So where was it moving to the left? Between 2 and 5. So between 2 and 5, we take the absolute value of the integral. Not the integral of the absolute value, but the absolute value of the integral. You can do the integral and then just change its sign as appropriate. Okay? You have to be careful. The one above, B and C, are not the same thing. You have to understand, if I'm finding the total distance, I have to deal with negative motion as well as positive motion. Okay? I have to deal with both of those. So you've got to be careful about that. That's the big thing about this. And frankly, I've done this because it's easier than doing this. You can only do this on a calculator. You have to know what your absolute value is on your calculator, how to find it, how to take the absolute value of something. Your calculators will do it. You need to understand and know how to do that just to make your life easier. Okay? But I also do it this way to do it by hand. Okay? Questions about this? And I have a ton of other questions I can ask about motion, right? I can ask questions about acceleration. What's its acceleration at a particular time? Ooh, take the derivative and plug in that value. I can do other things. Lots of questions about this. This is just the new stuff we haven't talked about before. Okay? Now, do not copy this graph, because I have a handout. Nice that way. It's helpful. What's going on? You don't have to. The only reason they're different colors on here is because that's the way I graphed it using Desmos. I decided I didn't want to make them all the same color, so I was being lazy. But I created that graph on Desmos and then pasted it in. There's another graphing program that I keep forgetting to ask them to give me to put on the computer. So I'll probably see if I can download the free copy from the while so we can get some stuff together. Graphmatica. I've talked about that in here before. Stuff we are doing after today in this chapter, Graphmatica is absolutely awesome. It does stuff that Desmos won't do. There are two things that it does that Desmos won't do that are really cool. One of them is slope fields. So if you want to go back and do some slope field stuff, Graphmatica is great. You can download it on Apple products. They don't have it for Androids, and you can download it for your PC. Any Apple product it'll work on, and PCs will work on. Sorry, no Samsungs, none of that stuff. They just getting the program to work with the Android base just doesn't. They haven't been able to figure it out. Work well, I should say. Okay. The other thing it does is when we do areas and volumes, it does awesome areas and volumes. I have it on my iPad. I love it. I used to have it on my computers. It used to be free for schools. Now they charge, but it's minimal charge, but it's for the school. For students, it's still cheap. It's like $5. It's like I've paid for 2 apps on my iPad. I've paid for 2 apps on my iPad. That's one of them. It was like $5 for the app. It's worth it. Okay, other than that, I'm cheap. I don't pay for apps. If I have to pay for it, it's not worth it. Okay. So, graph of the velocity of a particle. Do I know the equation? No. Can I find the equation? Yes. I don't care. The graph of the velocity of the particle moving along the x-axis is given. The particle starts at x equals 3 when time is 0. So its beginning position is 3. Part A, find where the particle is at the end of the trip. B, find the total distance traveled. I have this question up for a very good reason. Many students forget how to do integration if they don't. I don't know the equation. How am I supposed to integrate? How am I supposed to find it? Because for part A, your answer is where it started plus the integral from 0 to 10 of v of t. Right? But I don't have the equation. How am I supposed to integrate it if I don't have the equation? I hear you cry. I'm like, okay, go back old school. What was the first way that we did integrals? Area. Calculate the area. Everything below the x-axis is negative. Everything above the x-axis is positive. Take a moment. Calculate the negative and positive areas. Write them on the little graph. That's why I gave you the graph. Okay. Okay, so the first one, what's it say? What's the area right here? -1. What's the area of this one here? It's not 6.
Well, I can't tell what the base 2 is.
It's not 6. Okay, you go, how many squares? 1, 2, 3, 4, 5, 6, 7, 8, 9.5 squares. That'd be close enough. 9.5 would be close enough. 9.5 times 9.5. 9.5, and then 1, 2, 3, 4, 5, 6 across the top. So base 1 plus base 2. Trapezoid. You know the squares? Oh, I'm sorry. Can't you see what's up here on the board to match it up with what's on your paper to count it that way? Oh my God, really? Really? You can't say, well, I don't have it on my paper, but it's up here and it's the same graph, right? Oh my God. Come on, people. It's a soft spot, so it's not too bad. Okay, so it seems to be that we need to go back and review our basic geometry formulas. What is the area of a trapezoid? It's 1/2 times the height times base 1 plus base 2. The height of this trapezoid is 2. Half of 2 is 1. So it's whatever the base 1 and base 2 are. 6 squares. Each square is a half a unit. So it's 3 units across the top. 4.75 units across the bottom. 3 plus 4.75 is 7.75. This triangle, 1/2 times base times height. Well, the height is, oh, my bad. This one, my bad, I was off on that. Okay. Hang on. So the height here is 4 units. Half of that is 2. 2 times 1, 2, 3, 4, that's 2 1/4. 2 times 2 1/4 is 4.5. Negative 4.5. And the last one, 1/2 times base times height, -1 again. Same as that, just rotated. So, if I'm trying to solve this particular problem we were discussing earlier, this is 3 plus -1 plus 7.75 plus -4.5 plus -1 again. And you add all those together, and that's where it's at. Where it started, the 3 here. I don't know, what is it? 4.25. Part B says find the total distance traveled. Part B is the integral from 0 to 10 of the absolute value of the velocity, or the absolute value of all those parts added together. Because we're doing the area, that just means anything that's below counts as a positive. It's the absolute value of all the areas. Let's see, 1 and 2. 4.5. Sorry, I want to. My bad. So what do you get? 14.25. Okay, a quick word about the AP exam. They will give you the formula for the volume of the cone. If a cone is involved, and you need the volume. They will give you the formula for the volume of the sphere. If a sphere is involved, you need to know the volume or do something with the volume. They will give you the formula for the surface area of a sphere. They expect you to know how to find triangles and trapezoids and squares and rectangles and circles and cylinders and boxes. I do too. Give you a test that requires a volume of a cone, I give you the volume formula for the volume of the cone. Just like they do. Requires a cylinder or a sphere, I give you the stuff for a sphere. If it's a box, you can figure out a freaking box on your own. Okay? I expect you to know how to do trapezoids. And they do too. Now, here's the last part. Okay. This is a very important statement right here, right off the bat. The integral of the rate is how much? The integral of the rate, how fast something is changing, gives you how much we have used. So if we have, let's say, gallons per hour, we have an equation for the gallons per hour draining out of the tank. You can integrate that over a particular time period to find out how many gallons have actually drained out of the tank in that time period. If you know the rate, you can figure out how much. Any rate can be changed. And if you think about it, this is exactly the opposite of taking the derivative. You take the antiderivative to find out how much. If you knew how much, you took the derivative to find the rate. Directly related to each other. So here's a wonderful example. From 1970 through 1980, the rate of potato consumption in a particular country was C of T equals 2.2 plus 1.1 to the T power. Maybe a little bigger, maybe that'll help. It is a little faint. C of T equals 2.2 plus 1.1 to the T power. Bushels per year, with T being the years since the beginning of 1970. How many bushels were consumed from the beginning of 1970 to the end of 1973? So the integral of the rate. So what you need to do is you need to come up with an equation and then come up with the answer. The most important part of this problem for me is the equation. So the first thing you look at is what I have at the very top of the page. The integral of the rate equals how much? We're asked how much, so we need to know the integral of 2.2 plus 1.1 to the T dt. But what do we need to go with it? Bounds. This is an indefinite integral. We solve this. We don't have no. You need bounds to come up with how much. You got to figure out the bounds. Okay. Yes. In there. Okay. It doesn't start at 0, does it? Because what is the equation? When does the equation start? Years since the beginning of 1970. Are we starting at time 0? No, because we're starting at the beginning of 1972. So from 1970 through 1971, that's 1 year. 71 to the beginning of 72, that's 2 years. So we begin at 2. So our lower bound is 2. Our upper bound. When is our upper bound? The end of 1973, so it would be 4. If it was the beginning of 73, yeah, it'd be from 2 to 3, but it's the end of 73, which is the beginning of 74, so it's 4. 2 to 4. And dear Lord, do not try to even think about doing this by hand. Do it on your calculator. You cannot. This is one of those ones. This is an exponential that is taking the antiderivative of this. Really, really not easy. Can be done. I've been doing this often enough. I can see it. I know how to do it. Don't want to do it. Don't want to even think about doing it. Plug it into your calculator. Let the calculator do the work for you. That's what that tool is for. Yes, you can pound a nail through a board using your forehead. It would really, really, really hurt. So it's taking this integral by hand. Okay? Use a proper tool. You want to pound a nail, use a hammer, not your forehead. Okay? You want to solve this integral, use your calculator, not your forehead. Okay? Yes? I don't know because everybody's got a different calculator. And that's, honest to God, that's a different problem. I don't even remember how to do it on my calculator that I love because I forgot because it's been so long since I've done it. That's what one of the best things about this chapter is. Once you get it down, you will do it again and again and again. Okay. Google it, look it up online, and that's the best way to do it. Do not go to the manual for TI. It sucks. Okay. Questions? Check your answers with those around you. Make sure you all got the same answer because I really don't care.